Okay guys, so this is your types of chemical reactions lab that you're going to be working on. You should have gotten your handout in Google Classroom. You're going to be using Kami to type through the activity as we go along. And so there are some reactions that you're going to have to do in the boxes, and you will have to balance those and write the products. Now I'm going to go through with you and kind of tell you as we're going along what it's reacting with and what it's actually producing, okay? Make sure when you're here, you type in the appearance and what it looks like and things like that. All right, so the first lab that we're gonna do is gonna be a combination or synthesis reaction. Now remember, we've talked about this, when you are taking a synthesis reaction, so we have copper wire right here. So can you see the copper wire? The copper wire, we're gonna heat. It's nice and shiny, and we're going to heat it in the Bunsen burner. Now remember, when you're heating something, you're reacting it with oxygen. So that's where the synthesis part is coming in. So you're taking copper wire, heating it in a flame, reacting it with oxygen, and producing copper oxide. So the very first one that we're going to do, you'll notice as I'm heating it, it's going to get real red in color. So you have this shiny metal, and now you can see it's getting a little red, it's getting really hot, okay? And then after you do it for about a minute, I'm not going to do it a full minute because time constraints. So I'm just going to turn it over here and there. And now as you can see it, okay, can y'all see that? It's not shiny anymore. It's more like black in color, okay? So it turns from a shiny copper color, okay, to a black, almost like soot is on top of it, all right? So that's my synthesis reaction. So I now have copper oxide here. Now this next one I'm going to show you, you're going to like this one because this one's going to be extremely bright, okay? So this next one, you have Mg, so you have magnesium ribbon, and you're going to heat magnesium in a fire, which means you're mixing it with oxygen and you're making magnesium oxide, okay? So beware, this is going to be really bright when I put this in the flame, okay? So you go ahead and heat it, so you're mixing it with oxygen, okay? There you go, put it in here. It's very bright, as you can see, okay? Now I'm gonna bring it closer, and as you can see, when you're looking at this, you see the white, can you see the white powder in there? All right, that's the magnesium oxide, okay? So you're mixing this and making magnesium oxide after you heat the magnesium, okay? So that's it for my two combination reactions. Next, we're gonna take and make what we call or do a decomposition reaction. So I've gotten some powder. This is a copper carbonate. So it's green. It's a green copper colored powder, and it's we're going to decompose it into carbon dioxide gas and copper oxide. Okay. So I'm going to heat it in the flame, and you notice how I said we're going to produce carbon dioxide and copper oxide. Now we'll be able to see the copper oxide because it's going to turn black in color. But the carbon dioxide we're going to have to test for. So that's where this wood splint's going to come into play. Now, if you know anything about carbon dioxide gas, you know that it's in a fire extinguisher because that smothers a flame. So we're in essence, after we heat this, we're creating the gas that's in a fire extinguisher, okay? So how do we know, how do we test for this? How do we know we're creating carbon dioxide gas? Because we can't see it because it's colorless, right? And it's odorless, so we can't smell it either. So what we do is we can do a flame test. So we're going to light this wood splint on fire, okay? When we do that, it should act as a fire extinguisher and extinguish the flame. Now, when I do this, make sure you watch the color of the flame as it's going to extinguish it. So here's my flame. So now I'm going to stick it in here, and you can see a little bit it turns green. It's kind of hard to see, all right? But notice how when I pull it back out, it's relighting, okay? But now if I go a little further, now you see it extinguishes the flame. So I can relight this and do it again, right? Stick it in there, you get the fog, you see that little bit of green flame, okay? I'll do it one more time, and then you can see it makes a fog, okay, that comes out. So there you go. So now we created a fire extinguisher. That's how we can tell because it's gonna smother the flame and put the flame out, okay? So that's an example of a decomposition reaction. Now we're going to move into a single replacement. We're going to do two single replacement reactions. The first one we're going to do is one with copper chloride. So I went ahead and measured out, and you can see what it looks like. So that's 10 milliliters of copper chloride. It's blue in color. And then I'm going to take some pieces of ripped up aluminum foil, okay, and I'm going to add them to the test tube. So a single replacement reaction in which aluminum is going to react with copper chloride and produce aluminum chloride and copper. So now I don't even have to heat this reaction. Watch what happens. So if I hold this up here and I start hitting it, you'll notice that it's bubbling, okay? You can see it bubbling a little bit, and now you're going to see the color, okay? So you're going to see this little color of copper color that's starting to form. So what's happening is the copper is actually coming out of solution, attaching to the aluminum foil, and some of the aluminum foil is dissolving into solution. So you'll notice that the color of blue is actually changing because we're making aluminum chloride and pure copper, okay, because that's our products. Okay, so now you can see it bubbling, and actually it's warm to the touch. Even though I'm not heating it because a chemical reaction is occurring, it's actually warm to the touch, and you can see this copper that's forming, okay, all around the test tube. And I would keep going, and as you can see, you can even look at the bottom and you can see pieces of copper there, okay? All right, so that's a single replacement reaction between aluminum and copper chloride, and we're making copper